Hi guys, so today we are solving this problem called search a 2D matrix. Let's read it. You are given an m cross n integer matrix with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if the target is in matrix or false otherwise. You must write the solution in O of log of m into n time complexity, right? So in this problem, we've been given a target and we need to find that if it's like the target, is it present in the matrix or not, right? For example, 3 is present and we need to return true. And also we need to see where is it present, and if it's present, we need to return true. If it's not present, we need to return false. We need to solve this problem in O of log of m into n, right? So the simplest way is like just going a for loop and doing a for loop and iterating through the matrix one by one, and that would be of time complexity of n cross m, where n is the row size and m is the column size, right? So that is one approach, but we need to do it in O of log of m into n. So log of m into n, that rings the bell for me to use binary search. And because this array is essentially like each row in itself is sorted, and as well as if you see the row, each row is sorted in itself, as well as from like first row to the next row, right? All of them are having greater elements from the previous row, right? So the rows are as well as sorted, and every like all the elements in that row are also sorted, right? So distinctively the row betweens are also sorted, and every element in that row is also sorted, right? So we can use that approach to essentially create a virtual array like this, where we have all the elements written in like a one-dimensional array, right? So this is a two-dimensional array and this is a one-dimensional array, right? We don't need to create one, but we can assume that all these elements are essentially in this one-dimensional array, right? And we can perform a binary search. So low and high, right? And I just pick up a mid, so mid comes here, right? And similarly, and I'll check if the values of the mid is essentially smaller than the target or greater than the target. And if it is smaller than the target, I move the high to mid minus one. So high comes here, and I basically try to find a mid here. And I check if the target is less than or greater than. Here it is less than. So my high will come here, and I will try to find the mid again. And yeah, my target is equal to 3 actually, and the mid is equal to 3. So I return that value. So we can do that as well. But what is another approach? Like we can, instead of creating a virtual array, we'll actually just simulate it, right? So whenever we get an index, right, whenever we create a mid value, so I'm going to use that value and I'm going to just try to find it in the matrix itself, right? So if I just use that value of, mid, and I divide by the column size, right? So I get the row. So for example, I have, let's say, I want to find this one, right? 30. So 30 is at index 9, right? So 9 divided by 4, right? So 4 is the column, right? So 9 divided by 4, that would give me approximately 2, right? That will be 2.25, but yeah, value will be 2. So yeah, it's actually giving me the row column, and column would be mid modulo m, right? So mid modulo m, so 9 modulo 4, 4 will give me 1, right? So which is essentially the row is 2 and the column is 1, right? And moving forward, I will get the row and the column from those values, right? So I can just use that mid value, right? Whatever I create from the, like my low will be 0 and high will be basically be row, like whatever is the n into m minus 1, right? That will be the high value. and whatever is there in the middle, right? So middle will essentially be low plus high by 2, right? So whatever is the middle, I can get the row and column from it by middle. Middle will be divided by n, and middle would be modulo n, will give me the row and column, which will essentially be from the matrix itself. And I can just, instead of creating a virtual array, I can use this matrix itself to perform the binary search and find the value. And that will be giving me the complexity of O of log of m cross n, right? So that is the idea. Let's get to the coding part in order to understand this a bit better, right? So first of all, I will create an n, which will be size of the matrix, and m will be matrix of 0. So that will be my column and row and column, right, size. And I will create a low, which will be 0, and high will be n into m minus 1, right? So while low is less than equal to high, at that point, what I'll do is I'll first of all find the mid. So mid is basically low plus high by 2, right? That is the mid. And my row will be mid by 2, uh, mid by, sorry, mid by m, right? And column will be mid modulo m, right? That's what we said, right? So if matrix of RC is equal to the target itself, then we return true. Okay, that we found the value, right? Else, if matrix of RC is less than the target, then we say low is equal to mid plus 1. And else, we say high equal to mid minus 1. And that is the idea. And in the end, if none of these are true, we just return false, right? So that will be the code. Let's run it to see if everything is working fine. It works. Cool. I hope you guys understood the problem. Thank you so much.